we want to find the area of the shaded portion from this diagram. So these are the informations that we have here. We have this to be a rectangle, right? So this is a rectangle with a semicircle in it. This is not drawn to scale, but that is there, so the picture, right? Okay, now see, the key of solving this particular problem is to identify the shapes that are involved. It's very important to do that. So one, we have a rectangle here, a rectangle, and then two, we have what, a semicircle, right? So here is an assumption here. So if you're already on this channel, we have a short on this that maybe we would have come across that. But if you are new here and then you are going to gain some value from this video at the end, make sure that you subscribe to the channel. So if you have a half watermelon, right? So if this is a half watermelon, so half of this is what you are calling a watermelon, right? So a watermelon here. So half of the watermelon. Okay, let me fill that. So is that okay? And then we place these things in a rectangular so this is not drawn to scale, but just for an imagination purpose, right? So a rectangular box, right? So you place this half of the watermelon into a rectangular box. You can see clearly that if this is the portions of the watermelon, there should be some space behind, because that is somewhat a rounded shape, right? So those are exactly the space that we are talking about here. So how many space is going to left when you place that half of the watermelon inside that rectangular box? Is that okay? That is exactly what you are doing. That is just for an understanding purpose. So this can be applied into many fields, whereby in the constructions and other stuff, right? So you want to know the area that remains. So the key here, as I said earlier, is to identify the two shapes that are involved. First, you have the rectangle, and the second, you have the semicircle. You need to know the areas of these two shapes, and then you subtract the one that you place inside. So in this case, you are placing the watermelon inside the rectangular box. Is that okay? So once you're able to subtract the area of the watermelon from that of the rectangle, we are going to have the remaining part, right? Okay, so that is the key there. So here the information you have here to be 16. So if this is a rectangle, so you know some of the properties of the rectangle, that says that if here is 16, here is also going to be 16, right? So 16 cm. And then from the question here, so maybe I may post that question on the channel here for you to check. So we have the radius of this semicircle here to be 14 cm. Is that okay? I don't know if my pen is not free. So that's the 14 cm. So meaning that from here, so assuming this is the center here, so you have from here to this place to be 14 cm, right? So that is the radius of that watermelon. So these are all the informations that we have, and then you want to find the area of the shaded portion here. Okay, first of all, let's deal with the areas of the rectangle. That says that the length and then multiply by the breadth, right? So this is something we know, right? Okay, now how are we going to tackle this? So what is the length here? So how do you determine the length? Remember, pay very close attention. This is the trick here. You have here to be the radius of 14. So but we know the breadth here, right? So before that, we know the breadth. That's the breadth of 16 cm, right? So 16. So what about the length? So the length is what, right? We have the radius to be of 14 centimeters. So if that is the radius, you know the definitions of the radius, right? Right. So earlier when we know the definitions of the radius, that says that is, so if you have this to be a circle, and then from the center of the circle to one side, that is what we are calling the radius. So in this case, that is 14 cm. So if you want to find the full length, that is going to be 14 plus 14, so making what, 28. Is that okay? So meaning that the length here from here to the whole side of the rectangle is going to be 28. So if you multiply the 28 by the 16 here, what are we going to get? I think 448, right? So you check that for me. So 448 centimeters or square centimeters. So this is going to be exactly the area of the whole rectangle, right? So second, we need to find the area of something that we are putting inside here. so that we can subtract this one from the bigger one for us to have the remaining portion. If you are new here and then you are gaining value, once again, make sure that you subscribe to the channel. If you have any questions relating to this, make sure that you comment along in the comment section below for a better understanding. As I said earlier, we need to find the area of the semicircle. So talking about the semicircle, that is half a circle. So the area of a circle, that is the power r squared. So the semi means I have, so half of that, so half of the whole thing. Is okay? Pi is exactly that is going to be 22 on 7. So we know this thing already. And then multiply by the radius. So we have the radius here to be what? 14. That's going to be 14 cm squared. Right? So everything, I don't know how you are going to do. So a second, make sure that you solve this and then come back and come and check the solution. So congratulations for just trying, right? So you have here to be 308 cm square. If you're having a different answer from this and this one, just make sure that you alert me in the comment section. We have this diagram here. So this is a circle with a center B. Remember, the center can be any letter, of course. So whatever you have been given, you have to stick to that. Now here the whole question here goes down by saying that we should find the area of this shaded portion. So we should add the shaded portion. So you have the shaded portion here, right? So you want to find the area of the shaded portion. Okay, now how do you find the area of the shaded portion? So here's the whole question. We have this circle with the angle here that is at 60 degrees with some part of the circle being cut off, right? So whatever you want to pronounce this in a mathematical society, you may do that. Now here is the radius. You have a radius to be what? 5 centimeters. Right? Okay, once you have the radius to be centimeters, that is the whole question that we have here. So you want to find the area of the shaded portion. Now if you have a table, if you're already on this channel, you know how I've been doing this thing for some time and you already have a short on how to go about this thing. But if you are new here, maybe you may consider subscribing if you gain some value from this video at the end. Now if you have a table, so this is my very beautiful table here, and I place a book on the table, right? So placing a book on the table here, now talking about the area of the entire table here, if I want to find the area of this entire table excluding that of the book here, okay, suppose the area of this book, the entire table here is, let's say, 50, right? So assuming that is just 50, you may add your unit to that, and then the area, the portion in which this book has been taken should going to be, let's say, 10, right? So if you want to calculate the area of the entire table, we are going to subtract that of the table from that of the book here, sorry, so that of the book from the entire table. Is that okay? It makes sense when you can visualize this thing in that way. So that's going to be 50 minus 10, so we are going to have a 40. So talking about the area of the table excluding that of or taking away that of the book, we are going to have 40. Now bringing this idea in this particular portion here on how to solve or how to find the area of this thing here, all that we are going to do here is that we are going to subtract this guy here from the whole size or the area of this circle here. Is that okay? So that's the pi r square here. We know that this everything here sum up to 360 degrees. That is by definition, right? So here everything here is going to be, that is the entire circle, including this portion here. We know that is something that you know. So in starting solving this problem, you must always know something, right? So here we know that the area of the circle, everything is sum up to 360. So we have to take this portion out, right? So this portion that we have been given to be 60 degrees, you must take that out. So that's going to be 360. Well, let me change this pen. My pen is not working. So here is that is 360, and then minus 60 degrees. So here we are going to have 300 degrees. Is that okay? So now that is all, 300 degrees for everything here. Now pay very close attention. What is the question demanding? Someone may say that once you're able to subtract this thing, we are done. No, we are not done here. So that is just for this particular portion here, right? So that's the angle subtended, right? Is that that's the way? So angle subtended to this particular portion here. So how do you find the area? That's the area of the sector. So the entire area of the sector here is exactly what we are going to look for. So remember, we are also giving one information here to be what 5 centimeters, right? So that is the radius. So in solving mathematics, you have to make sure that you make good use of everything that has been given to you. So you have the angle here, and then as well as you have the radius. So where exactly are we going to use this in? That's where this definition comes in, by saying that. So talking about the angle subtended, so that's the word, right? So subtended, subtended, right? So that is the word here, subtended. So talking about the angle subtended, so that's exactly what we are finding. So we are going to find the area of the whole sector here, right? So that is where you have to come across this formula that is saying that by theta on 360 degrees multiplied by pi r squared. Is that okay? Remember, the pi r squared is just the area of a circle, right? So that is just the area of the circle. So this portion is exactly what we are looking for. So this thing here goes to this particular line here. Are you getting the point? So the theta here is no more going to be what, 60 degrees, but rather 300 degrees. So that is the area of the entire shaded here, right? So this 300 here relates to this particular portion. Are you getting the point? Okay, so perfect. So you just need to substitute everything inside and then proceed from that particular. So theta here is going to be 300 degrees. I believe at this point you can easily solve this and multiply by pi, that is the 22 on 7, right? So multiply by the radius, that is the 5 squared. Okay, so what will be your answer? So you may try this thing in the comment section below, and then for us to verify if you wish.